Hello everyone, so welcome to the Decentralization Code Cohort session 4. Yes, we have been looking at many things, at why you should be here, the opportunities. We looked at the gateway, which is the wallet, why you should be very careful with your wallet, why it is the platform that will help you communicate and transact on your given blockchain, or even participate in the products that are built on the given blockchain. And today, we are going to talk about what really is this blockchain. We take an analogy of the blockchain. We take an analogy of mobile money. So what we have, you can deposit. So you can choose to say, I want to deposit. And then for you to deposit, you need to go to a merchant. Let me say here we can have a merchant. So this could be a mobile money agent, and you go to them and say, I want to deposit. Then you can, after depositing, you can have an entire sort of suite you can do. Let me say you want to send you want to receive you want to buy airtime and other services. Airtime, so on this deposit you can have lots of things you can do. So send, receive, and let's say buy airtime. And airtime. So these services are done because you made a deposit. So if mobile money was to be decentralized, that means that first of all, we could know all the money that is in the pool of mobile money. So it's on the blockchain. Every participant can know that, okay, mobile money is storing this $1 trillion or worth of shillings, maybe could be worth of dollars. So yeah, these dollars are being sent. Hello. You guys are most welcome. Yes, so we are 27 minutes in, and today we are I can have a recap. So today we are going to look at what exactly is this blockchain thing. So yeah, and we are not just going to go into definitions. We really want to go deep. Given that on Monday we looked at why we should be here, the opportunities that could be available. On Tuesday, we looked at the gateway and interactions with the many platforms that are built on blockchain. Today, on Wednesday, yesterday, we looked at our first dApp. Today, we want to know what exactly is this blockchain thing. So, taking an analogy of mobile money, I think we all know mobile money. Mobile money, we use it for transacting, for sending, receiving airtime. So the way we get access to these services is we have to deposit. So depositing, you give money to a merchant, and then they credit your account. They put money on your account, the equivalent on your account. And then when you're withdrawing, you get money from them, and then they debit your account. But if this were to be sort of oh God, okay, I think this will be good. So if this were to be like okay, so this will work for me. If this were to be like a blockchain, we would have, let me share again. So, okay. Yeah, so if this were to be a blockchain, we would have opportunities. For example, we could not have issues like freezing, we could not have like loss of money or transacting it anywhere, and we are going to see how it can be turned into a blockchain. One is the participants. So when you give your money is stored as a record in a database, so in the ledger of maybe MTN or Airtel. So this record of money is stored in a centralized database. Now, this database is prone to security risks. It can be hacked, denial of service attacks. Sometimes you come and you click on you want to withdraw, and then the service is not available. It could be a denial of service attack. Sometimes, it can be many things, but that's one of them, denial of service attack. Others can be security issues where your balance may be stolen is compromised or sent to another person, and things like that. In a blockchain setting, what we call decentralization, we have what we call decentralization. And decentralization simply means that not one entity has a copy of the chain. So in the case of mobile money, your money would be put on the blockchain, and the nodes are the different computers holding the database of mobile money, could all have a copy of the ledger when it is being updated in real time. But we are going to be moving slowly. So how do these nodes then update their ledger whenever maybe a right transaction is made? How do these computers, having a copy of the block of the database in this scenario we are using mobile money, how will they update? They update through what we call consensus. So consensus is simply a set of rules. Consensus mechanism is a set of rules that the blockchain decided that would be agreed upon to ensure that the transaction being made. That means that if you go and deposit and this person credits your account, the transaction being made or any mechanism of writing that on the blockchain being made is true in accordance to the set of rules. So we are going to be seeing this in practical. And as long as there is this set of rules, then it is easy for the holders of the copies of the blockchain to always update whenever a right transaction is made. And this is also one of the things that calls for security. So in case, for example, the issue we had that we couldn't access mobile money somehow, in case one computer is compromised, that means one node is compromised. The rest can keep the chain running, and they will have the exact copy. Or in case someone misbehaves, the others, based on consensus. Consensus is simply like a set of rules that a group is agreeing upon a group is agreeing upon. So based on the rules, if for example 9 out of 10 have the same record, and one out of 10 has a different record, then the other 1 out of 10 by means of by means of this, the consensus will be like wrong, so they will be cut off from the chain. We are going to be seeing that. Then the other thing, we have talked about decentralization, consensus, security. So because we don't have one attack vector, the chain cannot be attacked by one entity, then at least it is considered to be secure. And then the other thing people talk about is transparency. Transparency, that you can see the transaction coming from a given address to another address. Yeah, so let me just type them and then we look at it in practical. Transparency. The third thing, which is very crucial, is immutability. So after a transaction is added on the blockchain, in a scenario, if us getting mobile money was a blockchain, that record cannot be erased, it cannot be removed. So immutability means that the record added on the blockchain cannot be changed. Yeah, that means after adding the record on the blockchain, and the different participating nodes have agreed that sorry about that have agreed that actually this transaction is right, and then they have updated their ledgers, then that cannot be changed. So that data cannot be changed. Whereas, for example, in our databases, maybe the mobile money databases, balances can be changed even because they are in a single database. But here, as long as a record is added, it cannot be changed. And that also brings what we call transparency. You can see the transactions that happened since the Genesis block. And what is the Genesis block? The Genesis block is the first block that was mined or was created when the blockchain is starting. Okay. So we are going to look at these in detail. One of the things I really love that explains blockchain, one of the websites, is this one. I would urge us to try out like the practicality, which I'm going to be doing. So right here, there is this try blockchain in your browser, and yes. So what happens is when we submit a transaction, since this data cannot be changed, so the blockchain's database grows so quickly. So what they do is that they compress this data using cryptographic methods, and one of the ways of compressing the data is through hashing. So using the SHA-256 hashing method. So what is hashing? Hashing is really a mechanism by which all the data is compressed and a representation of it is created. So whatever you write, actually, hashing is one way in a way that if I hash something, I cannot reverse it. So let me say here, if I put 1, this hash changes, but its length or its weight, the weight of this data does not change because the length is not changing. The length of this is not changing. So meaning that what happens is as these transactions are being recorded on chain and getting hashed, even when you fill this with many things, the hashes keep the data minimal but also secure. So yeah. So that's why that's one way by which we can these blockchains can hold our data, because since the blockchain starts till the time it is, till when you find it, you can actually trace every transaction back from the genesis block to the current block. So, but also hashing is deterministic, meaning if I type here 1, my hash starts with 6b8, and if I come back and type 1 again, I'll have the same hash as the output. Now this will really compress the data cryptographically so that it is kept on, so that the blockchain can keep our records without tampering with them. Those are the very good things of blockchain, and we are going to be going and exploring on this. Tracy, you're most welcome. We're explaining what exactly is this blockchain. We saw the opportunities, we saw how you can participate. We built our first DApp, and today we want to again just go back and know what exactly the blockchain is. What is it exactly? And from there we can, proceed. So that's one thing about hashing. Now for a block, what happens is you'll have to create the hash, you get the block number. So a block is like you have very many transactions and you are combining them together. So, and then you will sign on that block. Yeah, this is what happens. Because for us to know that the block was not tampered with, there must be a sort of sign to the block in case someone changes the sign. So here, for us to get the hash must start with 0. For this block, the hash is starting with 4 zeros. So, and it is block number 1. So if I change this to 709, this hash will change. And this background shows that actually you tampered with the block, with the data in the block. So the nonce is the signature sort of that we are using here. And if I go back to 8, it changes. But you can have a different nonce and then remine the block. Mining the block is like, in a blockchain, it's like you verify that the block is correct, and then you send that proof to that verification to other nodes to prove that actually, based on the data it didn't change. But for this, we are still just having a nonce. So if we change a nonce to maybe 707, we must have a different hash. And for us to mine, whenever we mine, it will always come back to this nonce for us to get the 4 zeros. But if we add data, maybe now we are tampering with this block, we are adding another transaction that happened into this block that was mined. The block also changes, but this changes to show that actually the hash has been tampered with. And then when I mine, it goes back to this, but now we are having a different hash. So we cannot have the other previous hash. We are having a different hash and a different nonce as well. Yeah. So when you have your nonce, and we are going to be learning these terms, it will always give you the nonce with the specific data. With the block number with the given nonce, we will always give you a deterministic output hash based on the mining criteria of that block. And now if you want to put this data into a blockchain, so for a blockchain, what happens is, yes, Benjamin.
Sorry, I'd just like you to comment
on the previous? On which one? On the nonce? Yeah. So here the nonce is acting as the signature. So a blockchain is a chain of blocks. And actually, how do these chains come? You'll have one transaction. And this one transaction, somebody creates also their transaction, and and another person creates a transaction, and these transactions are bundled together cryptographically using a hash function. Why are they bundled together cryptographically using a hash function? To make sure that that data is compressed. To make sure that that data is compressed and the blockchain is not overwhelmed. The biggest bottleneck of the blockchain is the storage, since the data that is written on the blockchain is not changeable. Like, you cannot come and update and do CRUD on the blockchain. When you write something, when you deploy a smart contract, if you've made a mistake, you simply deploy another smart contract. But that previous smart contract will always stay on the blockchain. It's the same with transactions, with what the transactions that are created on the blockchain don't change. So when this data is compressed and put together into what we call a block, it is signed on to make it is signed on, and that signature together with the block, the signature, the block number, and the data are compressed to form a hash, which will come based on the criteria that the blockchain, or based on the set of rules that the blockchain decided. So for this, the nodes together with the block and the data, so the data, which is nothing, create a hash function that starts with 4 zeros. Yes, and this hash function is SHA-256. So in case I tamper with the data, that means that in this block, maybe I want to add a transaction that didn't happen. The block will be invalidated. But again, for example, there is what we call forking, and where it's called, where the blockchain can be rolled back. So in such scenarios, when the blockchain is rolled back, let's say, for example, at the beginning of 2025, we had one of the biggest heists in blockchain, where a group stole 1.4 billion worth of ETH from the Gnosis Safe wallet of Bybit, and they were proposing that there is a rollback. So a rollback is to go back to the blockchain, to the transaction before the transaction that maybe was erroneous happened. So the blockchain is rolled back, and then a fork, a new sort of chain, is created from that time. Yeah. So whenever I change this data, the chain will show that actually one of the things that are added on this blockchain is on this in this block is wrong. So, but if you want to rectify it, maybe if you want, for example, this to have the code based on the consensus rules, you could mine it. The mining process is the work input. Mining is simply, it's like creating a nonce that when hashed with all these other entities, it will at least form the same pattern of starting with 4 zeros. So that is based on this example. It's not always the same, but based on this example, for a block to be considered right, the hash functions, the hash outputs should begin with 4 zeros. Yeah. So when we tamper with data, we can try to mine, and then the nodes will automatically change, but you will not get the same hash. So those incidences happen. But yeah, I think that's the explanation I have for the nodes. And okay, thank you. Yeah, so from this, we can now have the blockchain, and a blockchain is a chain of blocks. So what happens in one given block, we always have the block number, the hash of the previous block, the nodes, and the data. So the hash of the previous block is actually what creates the chain. Yes. So, for example, this is the first block, and we shall call it the genesis block. The genesis block is the initial block that was created when the blockchain was starting. I inquire, please give me a minute. Yeah, I'm back. Sorry for that. So, yeah, this data forms what we call the chain, because we have to have records of what what happened in the previous block, of the transaction of the previous block. So when you look at the block 1, the previous block hash is like 000 because we don't have any previous block, and then the hash based on the block number and the nonce is this. So if I change this block, if I change the data in this block, so the data in this block is empty data. If I change the data, you see that all the blocks after that block show that they are invalid blocks. So if I change data from here, let me say some people are trying to hack the blockchain. You see, from there, then all the added blocks will show that they have an invalid data. And if I mine, again, the last block, this will mine and get a nonce that will tally with a hash that will have 4 zeros at the start. But the last block, its hash will not start with 4 zeros because data was tampered in this previous block. So this is how blockchains resist changing of data. You cannot change data because when a block is created, it's signed on, and then the hash of the previous block is transferred to the next block as part of its metadata. So and that hash can be used to rectify that the previous block was not tampered with, because that hash contains all the ingredients of all the transactions, the nonce, and the block number of the previous block. Yes. So I don't know. So I mined, and then I don't know the nonce that was here. Probably I can just, think of, okay. So when you look closely, this hash is the hash of this block. This hash is the hash of this block, 0012. Yeah, and like that, this hash is this hash, this hash, which is the previous hash, is the hash of this block. So these hashes are the ones that help in creating the chains, and that's what we call a blockchain. So now we have one validator. One validator means one person, one computer that is enforcing the rules of non-tampering with this data. But then maybe that computer can be attacked through a denial of service attack. So what we do, we need other participants. So other participants are added to to a given blockchain, maybe through incentive, through being rewards. Some blockchain gives parts of the gas fees to the added participant to the validators who are other computers running a copy of that specific blockchain. So that's where they come in. Okay, so in distributed, now a blockchain should have like more than one participant. And let me see if I can. Okay, this will be small, so let's just take it the way it is. So now we have now like Ethereum, you can join as a validator, yeah, and you become one of the peers of the Ethereum blockchain. Even any other person, I think even Bitcoin, you can join as a miner. So you have peer A. If you look closely, peer A is like one validating computer or node running computer. Let's say node running computer. So the difference between validating and running a node is that running a node is simply running a copy of the blockchain, and being a validator is actively being involved in transactions being sent. So when you're running a copy of the blockchain, you're like a spectator. You can see every transaction that is happening. Your computer can see every transaction that is happening on the blockchain in real time. But when you're a validator, your computer participates in the security. So for Ethereum, you stake certain amount, which is 32 ETH, and then you run a node so that you can be a validator. So there are rewards for those staking rewards, and other people can stake to you. Yeah, so there are rewards for those people validating. Okay, so we have peer A, peer B, and peer C. So when you look closely, peer A has the same block with this hash 0015. It's the same hash with this peer B, and it's the same hash with peer C. So the reason why blockchains are called decentralized is that the set of rules that govern this chain make it so much impossible for you to change data. So for example, if we conspire and then we add more transaction in this block, so peer B or the person running a node on computer A adds 3 transactions, let's just put 3, and then mines this block, and they mine this block as well. Based on the consensus is like a voting set of rules for running the node. Peer B and peer C will look on the hash they have. So when you look, this hash is 00097. You see that peer B has 00012 and peer C has 0012 as their hash. So since the biggest number of validators have a hash that is similar, then automatically the block will identify peer A as a malicious node, and there are penalties for nodes that are running malicious activity. Yeah, but it will identify based on consensus, based on the fact that there are more blocks that are having the same block hash, since 2 blocks are better than since 2 node runners are better than the 1 node runner. So by vote, they will take 2 votes. They will have more weight compared to the first node run. So in case this peer A wants to conspire, he has to know the other node runners and also to engage them, so that he has more nodes having his transaction hashes, and then that will be taken as the right block. And we shall see some of these in the future, things like MEVs that some actors try to enforce to make sure that they enforce or they earn more money from transactions and things like that. But then a blockchain with just data is sort of like useless. So let's take a scenario where we have tokens. So when you look initially, we this is just focusing on transactions. We are not focusing on where this person has that money, had that money, let's say that token. So the token here we are having is dollar. We are just focusing that the transactions are not tampered with. So initially, when this block 1 and this nonce, so the data is maybe transactions, and there's $25 coming from Darcy to Bingley 4.2. We are assuming that they had this money, and 19 from Wikan to Lydia. So that means that Lydia will have this amount, 19. So at least the block 2 must have a copy of these transactions, of this data, and should validate that actually this person is transferring what they have. But here we are just looking at mainly at the records, that these records are not tampered with, so we don't know whether they had that money. But in case I tamper with any record, maybe here I put 26, even if I just change all these other based on the nonce and the data that has been compressed to cryptographically to create the hash, this will invalidate the hash, and that will make that an invalid blockchain or an invalid block. I have to mine, then also mine this, then also mine that. So if now we have an invalid block from peer A, that means that peer B and peer C will have a right block, right transaction hashes, and this will be cut off. This malicious block will be cut off, and then this will be taken as the right chains. Okay, but then let's look now at the concept where we can test whether these people had the tokens or not. I don't know, we are moving in a way. Any questions up that point? Or is it trying to come out? I'm speaking a lot of. Thank you, Aaron, for the thumbs up. Thank you, Benjamin. So, we are going to go and now look at where we have to even inspect from the start. So, we said that the Genesis block is the first block that is created. But the first transaction is called a Coinbase transaction. First verified transaction. So most of the blockchain, the first transaction, money is created out of thin air. And we know that actually fiat money is always created out of thin air, since it is just databases. So, and the logic behind money is simply the ability of the people to believe that money provides value. And the reason why we even have tokens is because people have come to believe that, based on the accountability, the transparency, the decentralization, that this store of value on the blockchain are a better way to store, to keep value or to transact, compared to the fiat monies that we have, since governments and a small group of people who have access can print at will, yet we have to work for it. So as we are working for the shillings and the dollars, there are some people who have the power to just write these digits in their database, and that money will now be in circulation, and it will be credited by banks. Yeah. So the invention of blockchain is an invention that is a better way to bring value to the public, or to store value, or to do transactions. It's a suggestion of a better way. Yeah. So the initial block, $100, was created out of thin air and created by Anders. So we shall say that you can actually create your own token in the blockchain, or your coin, and you can have a set of rules on who can create more money, more of your token, or if it is restricted and there is no more of that token that can be created. In instances like Bitcoin, it was the code was set so that there is no more Bitcoin that will be created apart when Bitcoin comes to 21 million. Actually, there is no more new Bitcoin created apart from the one created from mining. Other Bitcoins are just being transacted on chain, and Bitcoin is created from mining. And when Bitcoin hits, I think it is 21 million Bitcoin, there will be no further creation. But on blockchains like Ethereum, more ETH can be created by those who have maybe the admins or things like that. We have now USDTs. So we have the admin accounts for USDC or maybe on Coinbase. So they can mint at the discretion, or if they have a one-to-one in their reserves, they can mint more. So it depends on the way you write your code, on the way you've thought your logic. You can create your own token if you want to, or you can create some utility, and then maybe your token can be used to access that utility, to write or to buy or something like that. So here in the initial block, 100 of the token dollars was created out of thin air to the address of Anders. And then that means from that time, we can track every transaction. Where did money go? Because this is a blockchain, it is transparent. I can show one of the trackers we have. So Etherscan is one of the tools that I use to track transaction. You see that here we have latest block, and this is the block. So these are the blocks created, and we have latest transactions. So latest transactions are transactions that are going to create the next block. Yeah, so if I click, for example, on this block, I can see that. So the block is not yet finalized. That means that more transactions are being added to the block. Let me see if we can click on this. So they show you the block height, again, and for status, timestamp, block proposal on slot. So transactions that are being compressed in this block are 82 transactions and 141 contract interactions in this block, 16 withdrawals in this block. So Buildernet. So you can see all the information about that block. You can even look into the transactions that were carried out in that block. Okay. Yeah, so we can look at the transactions. It is not yet finalized. Yeah, so this one failed. So everything is transparent and is on the blockchain. So you can create a product that will query data and based on which data you want and show it. But we are still here. Hopefully here. Yeah, so from this, Anders has now $100. So I think Anders has a right to mint or print. So when we come here again on the block number 2, the first transaction on the second block, Anders also mints more 100 of the dollar token, and you'll see he will transfer this. He will transfer 10 of the dollars to Sophia, 20 to Lucas, and 15 to Emily. Now that means that Emily cannot spend more than 15 because she doesn't have more than that, and 15 to Madison. So the sum of this is 30, 50, 60. So Anders will have 40 more. And then when we come here and maybe we want from Emily to Jackson, $10. So Emily was given 15. Yeah, so she can transfer the 10. So in case I change this to 11, this will show an invalid block because the nodes that signed, because the data has been tampered with. So whenever you add the nodes, the block number and the other data and mine, you will now create a different hash which will show that this is an invalid block. But I can mine to make sure that at least, since one of the mechanism that validates this block is having 4 zeros, this is just for this block. But as soon as you are having those 4 zeros, and the nonce will change, so you now have a new nonce, and you also have a new hash. So that means that other people who are part of the blockchain will be asking themselves, why is it that we have different hashes? So since we can't tell, they'll look for the biggest number of, like, the nodes with the biggest number of nodes with the similar hash, and they will take that as the right block. Yeah, so if there are 50 blocks, if there are 50 node runners, and then 5 have a different hash, they will take the hash of the 45 and use it as the right block and take that as the right blockchain. So this other will be cut off. Yeah. And yes, so let me take this backward. So I can take back this to 10 and mine again. Okay. So that's how the blockchain works. That's how all the concepts come together, the security and the data and things like that. But then how do we sign? How do we write on the blockchain? So there is something. Should we stop a bit? So there is a mechanism called the private public key, and with the private and public key, it is simple. A public key is one that is like viewed with the public, but a public key will always have one set of a private key, and the private key will always be held by the person. So by the wallet or by the holder. It's actually not the wallet. It's just a key that identifies that the other public key has signed this message or owns this asset or something like that. And in any case, if this public key changes, this private key changes, you have a different public key. So for you to generate these private keys, they are generated randomly. That's why, like here, we just create a wallet. You can create thousands of wallets, like without anything. You just come and like the way we saw yesterday how we are creating MetaMask wallets. You just go and search for the wallet you want to. So let me say I want to have a Leap wallet. And once you create that wallet, you always have a public key. That is the public key that you share. Yeah. So I'm not going to get any other wallet because I really have very many extensions here. But that's the gist. Maybe I can show from here the public key. So for this, if I copy this, I'll copy the public. If I click receive, so this is my public key, and I can share it to someone to send me maybe a token. Yeah, and we saw how we get the public key from MetaMask. But as soon as someone has access to my private key, then they have access to my wallet, and they can use that private key and drain all my assets by simply transferring assets from my wallet to another new wallet or their old wallet. Yeah. So every private key will generate a new random version, a new random public key. Or every public key will have a different corresponding private key based on the mechanism that is used in this blockchain. In Ethereum, I think we use the ECDSA, but we shall look at it. So if I change these numbers, whenever these numbers change, the public key changes. That's why you can have hundreds of wallets. So this is actually what forms the wallet. So you can say, I want to create products, I want to create wallet products. This is what they do in the background. They call the method that creates both a public and a private key, and then assigns it to the way you've created, assigns it to you. So even here, now for example, one of the things we have is that our private keys are always like the same digits. So this same number of digits, not same digits, are always the same number of digits. I think they are 66. So they are created randomly, and every private key will have a corresponding public key. So the public key is what you share, and the private key remains yours to store, to custody your assets. A note to take, we actually don't store assets in our wallets. Our assets are stored on the blockchain. Our wallets just keep the access to those assets. So for example, if you lose your wallet, what happens is that your assets remain on chain, and maybe they are used to keep the security of that blockchain. But to access them, you need to use that private and public key pair. So if that question comes, where are your assets stored in the wallet, they are stored on chain but accessed through your public private key. So sometimes when you're sending data, we usually sign, and a sign is a proof that this data is coming from the private key of the corresponding private key for this public key. So for example, if I come here and I click verify, so if I come here and I have a message saying hello, this message is signed, and then I sign. When I sign, I get the message signature down here. So if I want to verify, if I click verify and I click on verify, this will verify. But if this message is tampered with and I click verify, it will not verify. So this is what is used to verify your message. Sometimes you will be seeing that when you're going to write to the blockchain, in your code you have things like msg.sender, which is the address, which is that your public key will sign that message. So when you write on the blockchain, they will ask you to verify in your wallet if it is MetaMask, if it is Ruby, and that's where it comes from. So when you verify, it's a proof that that address is the deployer of that smart contract, or maybe it's the sender of that money, or anything. Yeah. So whoever, in any way, if something is tampered with on that smart contract, the blockchain will resist that change, and the block will be nullified. Yeah, something like that. And even it is very hard to tamper with that, because based on the way the blocks are created. So we can go to a transaction and see through. So now we are moving slowly by slowly to the utility. So hopefully we are still on track. Is it becoming a bit technical, or it's okay? I'll take it. All right. Yeah. My storage, let me check. Still recording. This is not good. Yes, I really have to work on my storage, otherwise it will block out. So the next thing we are looking at is we are looking at now the transaction. So whenever you are sending a transaction, I want to send a transaction to another wallet. So these addresses are just interfaces built on the back end of this logic. And you can also choose to build your wallet. So when I click on send, you see they will say maybe I want to send link, and I'll have the address that I want to send to and the amount. So I have to sign. Okay. Let me just take an address. And receive. I copy this address. I'm going to send some Sepolia ETH. Okay, send Sepolia. Where could that be? Search for Sepolia. It is here. So I paste. This is the address, and the amount is 0.001. So when I press continue, they tell me to confirm. So here, account from this wallet to this address, network. And this confirm is the signing that actually, first of all, it is valid that I have that amount, and it is from my private key. Yeah. But as we are signing, you just see that it is from my wallet, but actually that's the meaning. So here, this is my private key. I'm sending from this to this. So if I sign the message, I'll get the message signature. And this message signature is verified on the blockchain that actually this signed, and this amount was part of the msg.balance of the address that I had. So on the blockchain, the blockchain will come and verify from the signature and verify whether this is a valid transaction. That's how the transaction is verified. If anything is tampered with, it will not verify, so the transaction will not go through. Let me try to make a transaction that will not go through. So here I want to send, let me say, I want to send ETH on base, and put in this, and then I'm sending 1 ETH, it will show insufficient funds, but if it is not gotten here, then the transaction will not go through. Yeah, so the wallet is checking whether my MST.balance, my account balance is equal or greater than this, the amount I'm putting, and before even I send, it's showing insufficient funds. Okay, then how do we now put this into a blockchain? So we have to compress all these transactions and then create blocks. So blocks are always of variable, like they have different transaction numbers. Some blocks can even be empty, others can have very many transactions, others can have few transactions. Some are having smart contract creations and interactions and things like that. So we again have a Coinbase block, a Coinbase transaction, where $100 was created out of thin air. Now to be more visible to this wallet. So I think this wallet maybe is the creator of that blockchain. Actually, this can be a very good encouragement for us. You can create your own blockchain, let it have utility, let it have a token, and maybe all you're doing is to manage that token. So you manage the money. As more people use your blockchain, you can mint, you can have the power, or you can have so some blockchains use a DAO, Decentralized Autonomous Organization, to decide whether to mint or to ban tokens and things like that. Okay, so this is the same thing, and now it shows exactly that you can actually track. So we know that this wallet OFO has 100 of this token, and then this wallet will send OFO to OFO-C, OFO-FE will send to 04C, and that must have a signature. So whatever you tamper with, if you tamper with the amounts, it will automatically invalidate the chain. And it will not just invalidate the block, but it will invalidate the signature. So I can mine this block and get a new hash that will suit the block, but this signature will stay invalid. And having an invalid signature will show that actually that transaction has an issue and it will not be accepted on the block. That's why we were seeing some of the transactions here. You see they have this, so transaction error. That's where it comes from. So maybe wrong values were sent. Then let me mine again so that other blocks can be corrected too. So you see that this block has many transactions. This one had one transaction. This has fewer transactions. So different blocks can have different transactions. Okay. We got something else. Today's session, I really wanted it to brief up, but it is becoming huge. So there is also something that is trending nowadays called zero knowledge proofs, but I think we can that's the concept of what a blockchain is. So I've shared this website. You can try out the demos, you can listen to the videos. Any questions? I think if I go further than that, then I will really I'll not have done you a favor. So these are the reasons why actually we are going for blockchain technology. Very transparent, decentralized, no centralized authority is managing. You always know what's happening, and that's why opportunities that were new, that were not possible before, like DAOs, decentralized autonomous organizations, sprang up. these work in a way that everything that will be happening on that blockchain is first discussed and then voted on by the members of the community. So this makes sure that the entire community is engaged, and then transparency, immutability. You can see that, okay, this is the total value locked, but right now we don't know the values, the amounts that are locked in banks. We don't know the amounts of money being printed, but in all these blockchains, you can go and see the total value locked in the blockchain, because everything is transparent, where money is coming from, where it's going. And with this broad knowledge, you can create products on top of these blockchains, or you can create products maybe for easy. You can create another Etherscan. So we have different explorers. We have the Block Scout team, the Etherscan team, and all these are different solutions that are created on these blockchains. And you can always ask maybe if it is funding from these DAOs, because if you create something that is valuable to that ecosystem, to that blockchain, that means that to bring more people to adopt the blockchain, and the value of the blockchain will increase. Probably the token value will increase, holders will increase, and that adoption, you can go into, for example, into their DAO, and bring your discussion, ask for bring a proposal, and then the members of the group vote to it. Maybe the treasurer of the blockchain supports or may not support. You could be voted out. So this is the experience of the blockchain. This is what the actual blockchain is. Any questions? So today's session, we could add on ZK if we still have the energy. Do we? Benjamin, Teddy, Sanyuka, Mobile. So if you feel we can add on zero knowledge, or we stop at least at that. Okay, so I think we can stop from there. Thank you so much. This session we really wanted to freshen us up. I think yesterday's session was a bit tough, so today we are bring us back to the concept. Tomorrow is Friday. Hopefully we get a way of breaking these issues down so that they are very, very easy to understand. Otherwise, thank you for attending this session. Have a great day. For those that want to have session 4, I think it is premiering right now. And yes, so we shall have this up as soon as possible. I'll see you in the next one. Have a great evening.